So I think we can start. Hello, everyone. My name is Svetlana Isakova. I'm from JetBrains, and I am Kotlin developer. Should we close the door or something? Thanks a lot. I'm Kotlin developer in both senses. I develop Kotlin on Kotlin. Last year we finally added. We have some. I think it's my computer. Sorry. Last year we finally added Kotlin code to our compiler. We started to use Kotlin in Kotlin compiler, and it brought so much happiness to our lives that I wanted to explain you why. And for those of you who bumped into this session accidentally, Kotlin is a language. It's a language from JetBrains. Who knows JetBrains or uses some of these? So their products, Intellij, or something else? What do you use? Intellij. Okay, Intellij wins. That's great. So we decided to invent another bicycle. Yes, our own development language. So Kotlin is a general purpose language. It can be compiled to JavaScript as well, but I won't talk about it much because it's in a more alpha version, and we'll talk mostly about Java code, Java bytecode, and JVM platform. Who is here an Android developer? Oh, that's great. So you might be really interested in it because, as you know, now Android Studio is based on Intellij platform, and so it's JetBrains product. And we have a rather good compiler for Kotlin because we develop a language compiler. We have rather good support in IDE because we are people who develop it. So we develop plugin, we develop compiler, and that's why you can easily use Kotlin in Android Studio. You just install the plugin and it works. Okay, so let's start. What's our plan for today? First, I will talk a bit about the whole motivation thing. Why did we start inventing another language? Why do we need it? Why do we think we need it now? Why do we separate it, etc.? And then I'll show you some Kotlin basic Kotlin features through Android examples. Basically, Kotlin is a modern language for industry. What do I mean by that? What do I mean by industry? What is Java really good for? Big projects, big teams, big companies. And it turned out that if you're a part of a big company, of a big team, the most time you spend on actually reading the code, trying to find the place that you have to fix, that you have to add some new feature, fix some existing bug, and so on. And so the readability of your code, the readability of your code base is extremely important. You can agree with it. And here we have a question, whether we can have as powerful language as Java for these circumstances, but more powerful. Because we know now more powerful and more readable. So our goals as language designers is to have more readable language than Java. We want our code to contain enough information for the reader, but not more. I think it's obvious that Java is really verbose. You have to write too many things that you can omit, but you can't because of the language syntax. And now, generally, in the world, we know how to omit them, how to make our language more concise. And that was one of our goals, to have more concise language. An example that you will see it for maybe in every introduction to new JVM language presentation. Like they show you this example and ask, what does this code do? And you answer, nothing. It just stores the data. Why do we have to put so many lines of code in Java to express this idea? And in all these new, better Java languages, we have the same approach. What we can do to avoid this verbosity, we can, in Kotlin, we can write something like this. Actually, it compiles to the same bytecode as in Java, but when you read it, it's more concise and more easy to read. Of course, in Intellij, if you use Intellij, you don't have to. When you write this code, it's not a problem. You generate it. I hope you generate it. all these getters and setters in IntelliJ, but the thing is different when you have to read it. Maybe not in IntelliJ that has good features to collapse all this verbosity, but for example, when you read it in GitHub or somewhere else, you have to see all this verbosity. Another example, in Java, we have static typing, but you can't omit, compiler do not enforce types very often for you. And you have to write your types explicitly all the time. So when you declare a variable, you have to write, okay, my variable has this type. And for example, if you check for another type, you have to declare another variable for it. And it's another small example. Well, Kotlin allows you to omit all these declarations. So the second quote in Kotlin has the same meaning as the first one, but it's a bit more easy to read. And that's the whole point. We have lots of such different examples when we know how to improve the readability of your code, and we allow you to do it. So that's why do we see why do we need Kotlin? So actually, this modern language, I would say that all these modern languages, that's all modern languages have in common. They are concise and expressive, like Scala, Groovy, Kotlin, etc. And now Java 8 has these lambda features that makes it more concise and more expressive. So we have no boilerplate, and we have power enough to let us to declare declare more abstractions, to extract more code into libraries. So that's a general idea. But what is the difference? And okay, but we have lots of such languages, and we have Java 8, not in Android, but anyway, what differs Kotlin from other, for example, better Java, new modern JVM languages? When we started Kotlin, I think 4 or 5 years ago in JetBrains, we have basically we wanted to write IntelliJ products, JetBrains products, on a new language. At that time, there was only Java 6 available, and because of we have big projects, we used to have very good tool support, especially JetBrains. Everyone knows all these IntelliJ features and so on. We need a good performance, and we want to have safety reasons. We wanted to have statically typed language. At that time, there was only one statically typed language, except Java, available. There is, 5 years ago, statically typed language, JVM. It's Scala, actually. Yeah, so only Scala was our choice. Java 6 or Scala, it was our choice. The desire was, we wanted to use a modern language. But it turns out that Scala isn't really appropriate when you want to mix it with Java. When you want to continue developing your Java projects in Scala, when you want to add your new code into your existing code base. It's not very good. It's good for like starting new projects and so on. So this requirement, Java interoperability, was very important for us in JetBrains, because the very important requirement was to continue developing existing projects. So we're very close to these differences from other languages. A small word about safety. We would like to avoid, so everyone wants to do less errors in your code. And now we know how compiler can help us with it. If we make a bit stronger type system, then we can convert some runtime errors into compile time errors. The most famous example is null pointer exception. The term was introduced by Sir Tony Har. He called it like $1 billion mistake, because no one knows how much money it costs us. These null pointer exceptions cost us, because this is a very common error, and very often people have to fix it. And there are some other examples. But the idea is that generally we know that we can fix it not in runtime, but in compile time. we now have, actually different module languages have their own approaches in this case. Maybe you know about Scala approach, option types, it's Java 8 approach to some extent as well. Maybe use annotations like JetBrains, special annotations for these nullability things, and so on. So there are different things how to deal with it. And we would like to have it in a language that it forces us to avoid these null pointer exceptions altogether. Good goal, isn't it? So here is my favorite table, where Kotlin has all its pluses, but no other JVM language has. And here is what we have. We have all these modern JVM languages are concise. So what I told about readability is concise means more readable code. Then we want to have less errors, more compiler guarantees for us. And last thing, very important, is this Java interoperability. And here, if a language compiles to Java bytecode, it's no problem to mix it with Java. It's a basic idea. Why not? It's Java bytecode. Java can invoke methods from another JVM language, and that's it. But it turns out that if we do not have these special requirements to be easily used from Java, then the language won't be easily used from Java. It means that if it, I don't know, maybe who tried to invoke Scala code from Java or Ceylon code from Java, it seems not like Java. It seems like something strange. It looks like, oh no, I'd better not do it. It looks like dirty, and you see all these internal implementation details of how Scala features are compiled, are looked at JVM. And if you don't have this goal, it won't be very easy to use it. And for example, this Scala has its own library, maybe you know about it, and it's not very easily mixed with Java code. So that's why we see the power in Kotlin. It's like it has all these modern features, but on the other hand, it's easily compatible with all your existing Java projects, systems, and so on. So as a conclusion to my introduction, Kotlin is smart enough to help you avoid boilerplate that you used to have in Java. It's expressive enough to help you avoid repetition in your code. It's safe enough to help you avoid several errors. So what's the problem? What's wrong with it? Actually, you may ask when we haven't released it. We haven't released it yet. And you can ask when Kotlin, when first version of Kotlin. We started the project like 4 or 5 years ago, and now we are almost there. But we have to fix last things, and for example, we have to rename trade to interface or something like that. So we have some fixes, and now I should have Hollywood teaser this summer. But don't take it seriously, please. Okay, so now we are going to demo, and I will show you some real examples. At first, I want to show you how easy it is to start using Kotlin in your project. For now, in Android Studio. For now, I will create a new Android projects with empty activity. And the thing is that what I've done beforehand, I installed Kotlin plugin. And what you have to do to start developing in Kotlin? Okay, we have to wait a bit when it downloads everything. And it creates the default Java activity for me. And what I can do, I can convert this Java activity into Kotlin. Actually, it's a very easy, very convenient way to learn Kotlin. We have Java to Kotlin converter, and if you don't know how to express something in Kotlin, you can write it in Java. Then, just copy paste this code into Kotlin file, and it will suggest automatically convert it to Kotlin. So then I will toggle presentation mode, and what I do, I just say convert. Convert. No, it doesn't respond. Sorry. We have to wait, I think. Yes. Convert. No. Convert Java file to Kotlin file. this one, but it's updating indexes. I'm sorry. So, but basically, what is going on here? I want to convert Java code to Kotlin. It just converts. You have Kotlin code, and then you can continue your development. And it's a very easy way to see how something is expressible in Kotlin. Sorry, it somehow presentation mode. And then, okay, I'll show you maybe in the presentation. At first, I convert Java activity to Kotlin or just copy paste. Then I have to configure Kotlin in projects. So just run this action, configure Kotlin project, and it does everything for you. And then you can write your Kotlin code in your project, and that's all. For now, we want, I think. Okay, I think we want. I won't show you it now, just not to waste time. But I hope you believe me that it works. Then no, if you want, I can do it. The next example I wanted to show you, there is some real Kotlin code examples. And the first one is, I think, an example with lambdas. Before it, I wanted to show you my very simple Android application. For this example, it's like just two buttons that answer thank you on click. And what do you miss in Java, in Android most? I think this lambdas thing. I hope that everyone here knows about lambdas and have heard about them somewhere from Java 8 or some. Who does know? I can explain. So actually, lambda is just your function stored in a value, and it's a syntax to express this function value idea. Here we have the set on click listener, and in Java you will create an anonymous object, but in Kotlin you have just used lambda. And what's the most interesting in this example is that this set on click listener is usual Java Android method. It's not our own we didn't add anything. It just works with Java. How it works? If we have special conversions, and if you have Java method that has as a parameter an interface with only one abstract method, it allows you to invoke it with lambda. So it just works. And for example, if you use RxJava in your Android application, all these lambdas will just work as well. So you don't have to do anything special for it. You just invoke this set on click listener and lambdas. Okay, a bit about lambdas and their syntax. So again, you can declare a value of function type. This is how function type is written in Kotlin. This is your lambda. There is a function that takes two arguments and returns their sum. And then, for example, you can declare this one a function that takes one argument and a function. So you can use lambda as an argument. And in Kotlin, we have a very nice convention that we will use later. So please put it in mind. We can move it's called move lambda expression out of parentheses. And the syntax, the thing is that you can put your lambda outside your round brackets. We'll use it later. But it allows us to build some more like DSL syntax things. And it's a bit more readable. A very simple example. Okay, so then if you heard about like Java 8 modern lambdas features, you know that they can, so the whole world outside Java 7 and 6 knows that and uses these filter map functions on collections, and we do have as well. So for example, you can use lambda to say that, okay, let's give me the collection of numbers that, I don't know, more than 2. Yes, and then, for example, you can map this collection into collection of strings, saying this, okay, please map me to like S and something like this. This is string template, and I think it's obvious that it will have the strings S1, S2, no, here it's like S3. So who thinks that it's very obvious that this example here, hello? I think this should be very clear. And here an interesting question is how it works. Because as I told before, we want Java, we want to be very easily, we want to have very easy Java interoperability, interop. And we wanna, we don't have our own collections. It's a very important thing when you interop with Java, because in Java you have your standard collection libraries. And for example, in Scala they have their own collection libraries. And when you have to interop, you have to every time wrap your one collection to another collection or something like this. It's very inconvenient. So in Kotlin we don't have this. We have Java collections, usual collections, and they work with Java very simply. But we have, like in Kotlin, we have to some extent the improved version of Java collections. And this list of actually returns us usual array list, usual Java array list. But then you can call we have a bunch of extension functions to these Java collections that you can invoke on them. That's how we make Java collections more readable and more easy to use. So this filter is an extension functions. I'll show you what is it. Maybe you know someone knows C# or looked at it. Oh, okay. So they have these extensions functions at C#, and if I'm not mistaken, we have stolen this feature from C# to some extent. So what is this extension function? You can extend your existing class with, for example, Java class. I think everyone in every project you have this string utils class with extensions to strings. And in Kotlin, you can just write it in a more beautiful way. You can extend your existing class, and actually, it won't change your class. You'll have just a collection of static methods. In this example, you can extend Java string class with a function last char. In this body, you can use this. It's like a syntax thing so this string is this in the example. You can omit this as usually. So here it's the same example as before. And this this feature is the other thing that I want you to remember because we will use it later. Okay? This omitting this. Yes? Questions?
Is this distinct from exit?
No, I think if I'm okay, maybe I don't get the questions correctly. Okay, maybe. Okay, I will try to answer it later, a bit later. The thing is that why do we need these extension functions? Of course, your string util functions just work, and that you can cope with them nicely. But in Kotlin, you have these extension functions are visible in completion. And at first, they are more readable. And secondly, if you want to complete, for example, here, and for example, if you use smart completion, it filters out everything that is not appropriate for the context, and here it is visible. So when you have all these extensions, they are visible in completion. It's much easier to write them down, and the code is more readable. Unlike C#, you have to import them explicitly. So here these functions are visible because they are in the same package. But basically, if you want to use your extension functions, you have to import them. And then they're visible and so on. There is an interesting question how it's implemented and how it's looked from Java. We have declared this last char method, and we can call it from Java. It is compiled to static method in a package. We have this util package, and we generate a special class, util package class for the package, and in Java, it's just your usual static method. And again, that's why we call this Java interoperability. We have these extension functions in Kotlin. They are nice, that can be easily found, easily invoked. But on the other hand, when you use them from Java, you can use them like your usual Java, and your string receiver here is just your first argument. Okay, so I hope that's very, very clear. Then what I wanted to return to lambdas thing. So now we understand this filter function is just an extension function on a class, on your collection class, and you can invoke them easily. Then there is an interesting implementation detail. Maybe you know that when you use, what's the problem with all these anonymous objects? When you use anonymous objects from Java 6, you have all these classes, anonymous classes created in runtime. That's terrible because there are lots of them, there are tons of them, if you use lambdas in your code. Then in Java 7 and Java 8, they have invoked dynamic, and in Java 8, they implemented them in a better way. But in Android, we don't have it. What we do in Kotlin? Actually, in Kotlin, if we can, we inline all these lambdas. So this filter, so for this lambda, in this example, an anonymous class, no anonymous object will be created. No anonymous class will be created. This code will be inlined. What does it mean? It will inline all the filter method body, all the filter body with the lambda that you invoked, and you will have your code like you would write it without this filter function. So the general idea is that in Kotlin you won't have this overhead. You can use lambdas if they can be inlined. Actually, this filter function is declared as inline function. Here, this inline annotation, and you can inline not all the lambdas, obviously, because if, for example, if your function uses your lambdas, invokes your lambdas recursively or something like that, it can't be inlined. But if it can be inlined, as like for most of the function, it will be inlined, and you won't have this overhead. Okay, let's return to our main activity. I wanted to talk a bit about nullability and then to go to more interesting examples. What about nullability? Maybe you have some questions that I can try to answer. Okay, but maybe later. So in Kotlin we have, in Java, if we see this button type in Java, it means that, okay, it's button type, but it can contain null reference. Yes? And the problem with Java is that you never know whether it can contain null or not, and you could check everything explicitly, but it is a crazy idea because it will spoil your code completely. But in Kotlin, we have two types of types. We have nullable types and not nullable types. And if I write down button like this, it means that it is not nullable type. And if I try to store null reference in it, Kotlin compiler won't allow me to do it. But if I want to be able to store null reference in the objects of my type, I will write button with a question mark like this. So here it means that I can save null reference in my types. So there is more words about nullability. What I show you is this. So I declare two variables. The first one is of type string, and that means I can't store nullable there. And in second type is string question mark, and if I try to store the null reference, it won't allow me. And what can I do here? I can't invoke just invoke their methods of usual string type on nullable types. The Kotlin compiler doesn't allow me to do it. I have this error, and what I can do, I can use, for example, this syntax. It was, if I'm not mistaken, stolen from Groovy. It means that if it's null, please return me null as a result. If it's not null, invoke what it's written. Then what I can, and there is a question, what is the type of this expression? Actually, it would be nullable. It will have nullable result. What I can do as well, I can, for example, provide a default value for null case. So in this case, if this expression is null, then return me 0 as a result. And now, okay, I can store it in a not nullable reference. What I can do next, I can check explicitly this case, yes, I'm sorry, this one. And actually, Kotlin compiler, here you don't see it, but we have so-called smart casts. And if you checked a variable for the type, you can use it as for having this type. It works with nullability, it works with other types. So here I can use it easily as not nullable type. And for example, I can write something like return, it will work as well. Or or I can invoke fail function that throws an exception, and then a compiler will notice that, okay, it's not null afterwards. So the basic idea is that with these nullable and not nullable types, compiler, on the one hand, it forces you to check all your potential problems. But on the other hand, it gives you lots of powerful instruments how to do it. In Java, you can only write if not null, then do something. It's verbose and inconvenient. But in Kotlin, you have lots of ways to do it, and it's easier to program this way. And then again, an important thing, how it is implemented. Because actually, for example, if you, if you looked at Swift, they have the same nullable types as well, but they are implemented as option types, like in Scala. So, but if you have option types, you have wrappers. Because option type, if you know what is it, it's like a special type that stores your value if it's not null, or another special value if it's nullable. And every time it's a wrapper. You can optimize it, but anyway, it's some overhead. But in Kotlin, we use the approach that we used in JetBrains before. We have special just annotations, nullable and not null annotations. So we generate just types with annotations. And in Java, Java code understands these annotations, but it just warns you if you try to use it incorrectly. So no overhead here. Let's again return to our activity. So now we know that here I have to do something like that to compile this code. But what I wanted to show you here is another thing. When I showed you my first example, I had 2 buttons there. So I want to have another button that is declared. And when I write this code, I'm, for example, as a newbie programmer, what can I do? I know that, okay, I have to add on-click listener on the second button. Okay, so what I can do? I can copy-paste the code and say, okay, let's do the same thing to the second button. But then I see this code and no, I shouldn't show it to anybody because it's terrible. You have this copy-pasting. And the thing is that Kotlin allows you to do a lot in this. Not a lot, but more. It gives you more power than Java code. In Java, of course, you have to somehow extract the copy-pasting code in a new method. But in Java, you might have noticed that you cannot always you are not always able to do it. And at Kotlin, you have more ways to do it. And this example is not like maybe very different from Java, but what I can do here to improve readability, I can use extension method as we know it. And now, I can write something like this. Yes, so I can, of course, it's not a big difference from a Java approach that allows you to extract it with the button as a parameter, but to some extent, it's a bit more readable. This power, you have this power with these extensions. Then you have here the default value for your argument, and you can invoke it with or without this argument, and it's a bit more. Again, it's a bit more convenient. Okay, so I'll finish with Kotlin basics, and now we are moving to more Android-specific things. Okay, and I hope this syntax, I hope this syntax is clear. And actually, I can here when my last thing that I want you to remember as well. Remember, you have two things to remember now. This syntax for lambdas and I don't remember. Okay, so now when I invoke this function, I can specify my argument name explicitly, and here write another text. Yes, and it's another thing that we'll use later. But anyway, now we are moving to Android-specific things. And now I'll show you how to simplify this code more. And in Kotlin, we have the plugin that's called Kotlin Android Extensions. You can install it easily. That cope with these findViewById problems. Of course, there is a problem in Android that you always have to invoke these findViewById things. And there are several frameworks that help you avoid it. But in Kotlin, we have the approach, the following approach. You can write like this. And here it's what was another button, and like this. And this works. And you don't need these findViewById things anymore. That's the most interesting thing maybe in the whole presentation. Except I'll have one more example afterwards, but this one is like the most beautiful thing. How it works. At first, what is it? What is this click me button? It is ID that I declared in my view. So if I navigate for click me button, it shows me this ID of button that I declared in my XML file. That's easy, yes. But how it works? But here this click me button has a type of button. So I can complete all these members of button, and I can invoke all these members of button. I don't have to explicitly write this type button as button like before. And how it works? Kotlin compiler goes through all your XML and generates their properties, special properties. Actually, this button in Kotlin, this click button, is extension property that was imported explicitly. Here. So here is click me. Here this is import where I got my buttons, and I can import them explicitly. And for example, if you have the similar IDs in different views, you can change this name while import. So for example, you can write like this, and this how it will be imported with another name, and you can use it here. So if you have different IDs in your views, you can change their names and import. So that's how to compile this. So compiler generates these extension properties that you can import and use. What's about bytecode? How it works? What is generated for you? This plugin generates for every activity written in Kotlin. It generates implicit map from string name, your ID, to your type of activity. So here it will generate a map and put then into it click me button string to button and button to button. And it generates this map. And for each Kotlin activity it generates this map. It is null if you don't use it, so it's not initialized. If you use this feature, it initializes this map and put here your value into this map. So then it means that when you use it, it will be the code generated for only this click me button string is please get the right element from the map and invoke it and use it. And if it's not, then findViewById as before and put it in this map. Is it clear how it works? That's great. So yes, there is like the must have nice thing in Kotlin that you can use just your IDs of use with import and easily invoke them. Okay, so now I want to show you another example. I need to, at first I'll show you here. It will be as simple as the first one, yes. It will just show me the time in 2 different points. I'm from St. Petersburg. Their main JetBrains office is in Russia, in St. Petersburg. So you see how tough it is for me to speak now and to go there because of this big time difference. But anyway, and I want you to show how I can write this small, very easy application with like DCL Kotlin's DCL for Kotlin for Android. Who tried to look at, for example, Scaloid? Okay, that's great. You will see something a bit similar to Scaloid, but very maybe remotely similar. So, builder, yes. Okay, so at first I have to look at my activity. So I'm, as you got already, I'm a newbie Android developer. So I prepared a very simple table layout for my example with a table layout, table row, and 2 like text view, text log. That's very easy. And what I do? I show you my application, but then I decide, but I want to add more locations to my application, and I would like to add them dynamically. So I would like to, for example, have a list of my possible locations, and somehow build an application that shows me all the time for all these locations. In Kotlin, as you show in the introduction, we have these data class notations that generates all these getters, setters that you can use from Java, and equals and hash code, and it works with JSON libraries as well nicely, so you can use these data classes in your Android applications easily. Okay, so I have these locations, and we see that my activity, and what I want to show you now is how you can declare the same layout, but build it dynamically in Kotlin. And what's going on here? So you saw we had this table layout, table row, text view, text clock. Yes? But we have to specify 2 table rows if we had 2 table rows. And if I have 3, I have to specify 3. But here is the code, actually. And what I can do here is I can just say, OK, please iterate over my locations and generate a table row for every location. And please text will be location text. And where is it? ID will be location ID. What is wrong? It's not text because it's name, yes. And then use location time zone, yes? So what's going on here? Again, it is the code. And there is a moment when you have to remember what I wanted you to remember. I mean, do you remember the convention with these curly brackets, yes? Curly braces. That it is just the last lambda of your function invocation. Okay, it's here, so this one is a lambda actually. This one is a lambda of function invocation table row. Table row is a function that invokes like function type as a parameter, and then you can write your lambda as an argument, and it looks like layout with the code, and it generates your layout, but actually it's like a function. It's just a function invocation. Another interesting thing, what I wanted to remember, I wanted you to remember that you can omit this, implicit this. And now I want to show you the most complicated feature in Kotlin. If you looked at Scala, you know that Scala has like loads of tons of very complicated features. In Kotlin, from my point of view, we have only one, this one, and everything else you can grasp very easily, and you somehow looked at it. But this one is the only new feature that, to some extent, wasn't stolen from any other language. And this actually, it's not just a simple lambda. It's it's an extension lambda, and it's a lambda that has inside this as an implicit receiver. And inside this lambda, you can use this. You can emit it, and this text view is a member of a special type that is appropriate for this table row. We can try to look at it. All these methods are generated for you in this library. So this table row, you see it has this is a syntax for these extension lambdas types, and you see that it is a specially generated table row type for you that you can use inside this lambda and emit this. So we won't go deep into details here of implementation. The general idea is just code. You can just use it, and it just works. Here in the example, what is not so good in exactly this example, from my point of view, is that in this example I mix, to some extent, UI and logic things. So this one is text, layout parameters. It's like your view things, but here I have this set time zone thing that is my logic thing. But I hope that these things can be divided in your code, and Kotlin gives you the power to do it. So you can, for example, extract to the libraries all your styles functions and use them, and write your logic in these builders or whatever. So it just gives you this power to organize your layouts like this. Okay, so how much time? Oh, we're almost there. So I showed you this example. Then the last thing I wanted to, so this I just wanted to emphasize that how we implemented some features, some things that would be emphasize that we are very concerned about the not generating not only verbosity but not generating overhead, some wrappers and so on. This is and about for Android is very important. What is exactly size of the runtime jars that you have to add to your project? And actually, I didn't count all these things. It's from Jack Wharton's article, in which he was, I would say, rather positive about Kotlin and used it in Android. And now we have this following version of Kotlin. But the thing is, why it is as small as you see? Because we don't have our own library. Again, we have only a bunch of extensions to Java standard classes. And we have just like several static methods added to your library. And you have this Kotlin runtime that is not very high, and Kotlin said believe that that you can actually you can eliminate with progress some of these of the classes. But the general idea is that we have because of this easy interoperability, you don't have as big jar, for example, as in Scala when they have rewrite everything, and if you want to use it, for example, if you can use, if you looked at RX Scala, you notice that they re-implemented everything to be able to use it nicely from Scala. But in Kotlin, you don't. The main idea is that you don't have to re-implement it. You can just use it as it is in Java, but with nice syntax. That's the main thing. And for example, in Groovy, because of the dynamic nature of all these things, they have this dynamic support in the jar, and it's not. I spoke with them. It's not as easy to just cut it off. So you have to have all this support in your jar as well. And as for libraries that Jake Mortens usually uses in his application, it's in that most of the libraries just work with Kotlin. For example, RxJava and etc. They just work. Only two doesn't. It's Dagger and Butterknife. But you don't need Butterknife in Kotlin because of this extension properties plugin. Because Butterknife has the same idea to generate this, not to invoke findById all the time. We have another approach. And as for Dagger, now it doesn't work completely. It surprisingly works a bit with Kotlin, so you can annotate your setters with inject annotation, and it works. And honestly, we just even don't know why it works, because from our point of view, it shouldn't work at all. But it's like one of our first priorities for Android to understand. Actually, the Dagger uses annotation processing mechanism of Java compiler, and it's a big thing. It's a big thing to support. And we want to do the same thing to support this annotation processing, but for Kotlin. But it takes time, and it's not an easy task. But it's at first we want to see how it works now. Maybe we can force it to work somehow for most of the examples, and then support this annotation processing or some other things. But it's our list anyway. A small thing about references. So the first plugin with IDs, it's called Kotlin Extensions for Android. You install it separately for your application, and obviously you can use it only in Android Studio, so it won't compile without it. It's a Gradle plugin. It won't compile, but for example, you wouldn't be able to open it in Eclipse, because it generates all these properties, and otherwise they won't be compiled. And the second DSL library. I forgot. The second DSL library called Anka, and what I forgot is I forgot to show you it has preview for you, and it's a new thing. We just loaded it into plugin repository. So in my previous presentation I didn't show you, but now it's a plugin repository, so I can do it. But we have to wait a bit for it to download. The problem here is that it works long. It compiles the code. It uses Turboelectric inside to generate some mock instances for you, and then okay, maybe it will work afterwards. But the idea is that you can see you can preview your layouts. And so this plugin is called Anka DSL Preview. And if we have a special like Kotlin Cons for those who like to learn Kotlin using some tutorials or workshops. For now, it's not for Android. It's for general Kotlin. But if you, for example, have your colleague who doesn't believe you, or you want him to learn Kotlin, you can give him this project. It consists of like several tasks that you have to fix, and while you do it, you learn Kotlin. That's the idea. Oh, it works. You see. It's very slow, but it works. It shows us all our examples for these dynamic layouts. So again, now it's a bit slow, and I'm not sure you can use it easily, but anyway, it will. Our second priority is incremental compilation for Kotlin for Kotlin and Gradle, and if you have an incremental compilation, it will work much faster, and then it will be much more usable in your usual work. Okay, thank you very much. Thanks a lot. Questions?
First, thank you for the presentation and for all the great work on the language. So I have 2 questions, actually. The first one is about, are there any major differences using the Kotlin plugin for Android in Android Studio versus Intellij Idea right now?
No, I think no. But basically, the main idea with this Android Studio and plugin for Intellij is that they pull all the requests. So if you use like the latest version in Android Studio, you have better Android support. In Intellij, you have better Intellij support. But then in several months, they will pull all the features from different repositories, and these should be equal. Maybe I'm not very clear on that, but the thing is, the main idea is that all the changes pulled from these repositories. And for now, I think it has no difference. For Kotlin, this Kotlin compiler just works in Android Studio, and that's it.
Okay, thank you. And my second question is about unit testing. Can you talk a little bit about, can you write JUnit style tests for Kotlin Android applications, and how would you go about doing that?
It just works. We have, so when I told that we don't have annotation processing, I mean that we don't have this important capability of doing something during compilation time. But we have annotations, we support annotations. You can write your JUnit annotations easily, and again, it just works with Kotlin.
Okay. Thanks.
Yes, thanks. More questions?
Hi.
I'm sorry, but can you use microphone or maybe? Sorry. I'm sorry, yes, but I just...
I have just a quick question. You mentioned the impact on the method counts for adding in the Kotlin library. But do you guys measure significant, I haven't read Jake Wharton's article, but measuring the impact on the method counts for the app itself, like having using Kotlin versus not using Kotlin?
Sorry, for what method counts for?
The method counts in the app for the, we have the 65K dex limit that everybody's always running up against. And so there are the libraries that you add that contribute to that, but there's also the app, code base itself. And so, using Kotlin in my Android app, is that going to significantly increase the method count of my app? Because, this is generating behind the scenes a lot of, extra utility classes and methods and things like that.
But if I'm correctly got your question, so what methods are generated implicitly? I didn't see lots of methods that were generated implicitly for you. So, for example, if you declare your extension method, it's just your extension methods in your application.
So method is a method.
It's just a method. Yeah. It's not like 10 methods or something. It's just a method in your application, static methods, in Java bytecode, and it's counted as one method, and that's all. As for extension and extension plugin, all this, what I saw, these extension properties, they are not generated into bytecode. They are used only for you to resolve and to use them. But they are not generated into bytecode. They are somehow inlined into the bytecode. And again, for lambdas, they are inlined as well. So the thing is that what you're written, you have it. And for example, in Java, what I wanted to emphasize when I told that you have more power to extract everything into libraries and to methods, that in Java, when you have to extract like small part of your method, you have to extract it into different method, and you have very long list of arguments, because you have all arguments of a previous method and much more. And in Kotlin, it allows you to extract it to a local function. It is much more readable, but actually in Java by code, it is the same. Because it just have all the argument implicitly. But argument method counts doesn't change.
Thank you so much.
Thanks. And please speak a bit slower because you see you all live in America and I'm not used to.
I will slow down. I apologize.
Yes, thanks.
Because I'm
Thanks a
roughly
lot.
in line with her. I thought you'd pointed
No,
to me.
yes, sorry, yes.
So clearly we don't have semicolons, meaning I presume that you've got some kind of a line continuation character.
No, you just
So if you had
new
to
line character, maybe.
imagine the case where I have a very long line that I want to wrap
Yes.
in order to make it readable in most monitors.
In some corner cases, it doesn't work. So it's like if you have, I don't remember. If I'm
So
not
you
mistaken,
don't
you can't.
support. Okay, so there
You can't start a new lambda in a new line or something like that without a dot. So there are very small corner cases.
Okay.
But usually they are
Understood.
they can be very easily work around it.
Roughly how many of those order of magnitude, how many of those adaptations or
How many
different,
adaptations?
so it's a difference, and I've run into this with Python and all the languages that look like bad C, but rough order of magnitude, how many things do you have to know that are not right in front of you?
How do you think?
That's not a fair question,
How,
I'm sorry.
how many things do you have to know when you look at Kotlin code or what?
We've got Java code on one side, and
Yes.
on the other side, you've got
Kotlin
Kotlin.
code. How easily it is for you to read Kotlin code if you don't know?
Right.
I would say that I've shown you this workshop project, and it's measured. It was measured that it takes you from 3 to 6 hours to complete it, this project, and after it you can read Kotlin code and write Kotlin code. So it's just as easy as this. Of course, if you complete it and then forget about Kotlin, it will be very difficult, very difficult to remember what is the name for function or for variable. For example, for now, if I have to write Scala to test everything, I have to remember what they have syntax
Yes.
for. But if you use it, the main idea is that it's very easily grasped. You have to.
I understand that. I was just trying to get a rough, a figure of merit for what the stylistic differences were. Thank you.
Okay, thanks you. Thanks a lot. If you have any more questions, you can ask me later after the talks. Now, thanks again. Thanks.